This is example 6.5 from Discovering Design with Chemistry. The problem says, a pocket lighter generally burns butane, C4H10. In the reaction, butane reacts with oxygen in the air to make carbon dioxide and water. So I've underlined the different reactants. Oxygen, remember, is diatonic, so it's O2. And then we have carbon dioxide and water. So this is the unbalanced chemical equation. The trick now is to balance it. So let's make our chart. We have C, H, and O. And we care about what's on the reactant side and what's on the product side. So on the reactant side, we have 4 carbon, 10 hydrogen, and 2 oxygen. And then on the product side, we have 1 carbon and 2 hydrogen, and oxygen shows up in 2 places, so we have to count those together. 2 here and 1 here. That makes 3. We could go straight across, hitting our C's, then our H's, and our O's. We could start with the hardest, we could start with the easiest. And so let's start with the ones that only appear in one place, and then we'll deal with that oxygen last. So because we have 4 carbons here and only 1 on the other side, let's start by putting a 4 here. That will change our carbon number and our oxygen number. So we now have 4 carbon on the product side, and we have 4 times 2 makes 8 oxygen over here, and then we have 1 more oxygen over here, so that's 9 total oxygen. Now let's fix the hydrogen. So this side has 10 and this side has 2. So let's put a 5 in front of this one. So that adjusts both our hydrogen and our oxygen numbers. So let's recount. So for hydrogen, we now have 10. And for oxygen, we have 4 times 2 is 8 oxygen in this one, and 5 oxygen in this one. So that means we have 13 oxygen. Now we get to a problem here because the other side has 2, and we need to be able to have the same number, but there's nothing we can multiply by 2 by to make 13 because 13's odd. And the book has you do it away with a fraction, which is kind of a cool way actually, but I think that it might be confusing for some of you. And so what we're going to do is we're going to recognize that if we had an even number here, where the 13 is on this side, it would make it way easier. And so to make it even, what we're going to do is we're going to go ahead and we're going to double the amount of everything, which is kind of what your book does, but it does it a little bit backwards. So first we're going to take all of our numbers and we're going to double them. So we're going to put a 2 here, and we're going to put a 2 here, and we're going to put, instead of a 4, we're going to make that be an 8, and instead of a 5, we're going to make that be a 10. And because the oxygen is really the only one that we're working with, we could actually take this 2 right here and we could erase it and fix it. But first let's count before we erase it and fix it. Alright, so let's erase all of our numbers in our chart and then recount. In theory they should have all doubled, but we're going to count anyways. Alright, so we have 2 times 4 makes 8 carbon on this side, and we also have 8 carbon on this side. Hydrogen has 2 times 10 is 20 on this side, and we have 10 times 2 is 20 on the other side. Oxygen has 4 over here, and oxygen has 8 times 2 is 16 plus 10 more, so we have 26. Now obviously we know that we can't multiply this 4 by anything to make 26, but this is where we're going to change it anyways. Because we inserted this 2 and we doubled everything, we can erase this 2, and then we can choose what we want to be there instead. Because there are 26 oxygen on the other side, and there have to be some multiple of 2 oxygen on this side because it's O2, we can just decide what do we multiply 2 by to make 26. That's 13. So if we change that 4 to a 13, and we multiply 13 times 2, now we have 26 oxygen on both sides. If you want to see the way the book does it, where it puts a fraction right here, where the 13 is, and then doubles the whole thing at the end, that works too. And if that doesn't confuse you, then go with that method. But for those of you who don't think fractions are super fun, this version might be a little bit easier. If you want to see the fraction method worked out, I'll go ahead and do that real quick. If you're done, you can just stop the video, turn it off, we're done. Alright, for those continuing, I'm going to rewrite the equation, and I'm also going to erase the chart so I can move it. Alright, so the equation we had when we were working with this was C4H10 plus O2 yields, and we had a 4 here, CO2 plus, and we had a 5 here. When we got to this step and we started counting our carbons, our hydrogens, and our oxygens, on this side we had 4 and 4. I'm going to just fill in these numbers quickly. 10 and 10, 2 and 8 plus 5 is 13. At this point, and the problem was where we did the doubling thing to get our reactants and our products to be easier to deal with. Instead, another way to do it is to think, what could I multiply 2 by to get the 13? Well, if I multiplied by 13 and then divided by 2, I would have 13. 13 over 2 times 2 is just plain 13, which is what I want. And so that would work. However, you can't have a fraction of a molecule, and so at this point, this is where the problem went through and doubled everything. So this became a 2. The 13 over 2 became just a 13. This 4 became an 8. And this 5 became a 10. So it ended up with the same answer, but to get there, we put a fraction temporarily in there and then doubled everything to get rid of it. If the fraction had a different number on the bottom, like a 3, we would have tripled everything. But for some of the trickier ones, sometimes that might work. But like I said, if fractions are not your friends, do it the first way that I explained.